In this video, we'll be going over another question where we look at binomial expansion. Now we have our question. Given that 2 plus x to the power of 5 plus 2 minus x to the power of 5 is always equal to a plus b x squared plus c x to the 4. Find the value of the constants a, b, and c. So what we're going to do is we're going to expand, first of all, 2 plus x to the power of 5. So to expand it, we're going to start off with 5 choose 0 multiplied by 2 to the power of 5 multiplied by x to the power of 0 plus 5 choose 1 2 to the power of 4 x to the power of 1 plus 5 choose 2 2 to the power of 3 x to the power of 2 plus 5 choose 3 times 2 to the power of 2 times x to the power of 3 plus 5 choose 4 times 2 to the power of 1 times x to the power of 4 plus 5 choose 5 times 2 to the power of 0 x to the power of 5. So this is our expansion. Now if we use our calculator to find all the values, we get each value as 2 to the 5 plus 5 times 2 to the 4x plus 10 times 2 to the 3x squared plus 10 times 2 to the 2 x cubed plus 5 times 2 to the 1 times x to the power of 4 plus x to the power of 5. And so if we multiply everything together, we get 32 plus 80x plus 80x squared plus 40x cubed plus 10x to the power of 4 plus x to the power of 5. Now we're going to expand 2 minus x the whole to the power of 5. And so to make life easier for ourselves here, all we're going to do is we're going to substitute minus x into the places where x is. And so from here, we're just going to have, so this is equal to 32 minus 80x plus 80x squared minus 40x cubed plus 10x to the power of 4 minus x to the power of 5. Now we're going to add these two together. And so even from this place, we can start to cancel out terms that are the same. So we have 32 plus 32, which is 64. And we have plus 80x and minus 80x, which cancel out. Then we have plus 80x squared plus 80x squared, which is 160x squared. Our 40x cubed and our minus 40x cubed cancel out. Now we have 10 times x to the power of 4 and plus 10x to the power of 4. So that's 20x to the power of 4. And our x to the power of 5s cancel out. So we're left with 64 plus 160x squared plus 20x to the 4. And this is in the form of a plus bx squared plus c x to the 4. Now a is equal to 64. B is equal to 160. And C is equal to 20. Now for part B. So we have here, using the substitution, y equals x squared, and your answer to part A, solve 2 plus x to the power of 5 plus 2 minus x to the power of 5 is equal to 349. So we have our expansion of 2 plus 5 to the power 2 plus x to the power of 5 plus 2 minus x to the power of 5, which is equal to 349. And so if we have our expansion here, so 64 plus 160 x squared plus 20 x to the 4 is equal to 349. So the question told us to take y as x squared. So for all our x terms, we're going to replace it with powers of y. So x to the 4 is equal to x squared to the power of 2. And since x squared is equal to y, this is equal to y squared. And x squared, we can immediately substitute that to y. And with rearranging our equation here, we can get 20y squared plus 160y plus 64. And now we're going to move our 349 to the left hand side. So we have minus 349 is equal to 0. Now if we simplify this down, we'll get 20x squared plus 20y squared plus 160y minus 285 is equal to 0. Now, if we use our calculators to solve this polynomial, we get our answers to y as y is equal to 3 over 2 or minus 19 over 2. Now, we want to find x, so we know that y is equal to x squared. To find x, we have to square root both of these values. However, we can't get a square root for a negative number, so we can remove our minus 19 over 2, and we can just take our value of 3 over 2. So x is equal to plus or minus root of 3 over 2. As always, thank you for watching and make sure you subscribe so you don't miss out on any new content.